Hello, everyone. Thanks for joining us again. We're here with JT Nesbitt, the mind behind the Curtis One, and we have another round of frequently asked questions that we get, and most of these are design and even more specifically manufacturing related. So there's no one better within Curtis to answer some of these questions than Mr. Nesbitt himself. So we're going to hop into it, and JT is going to enlighten us on some Curtis design and manufacturing knowledge. Ready, JT?
Yeah, I'm ready. Hey, everybody. Welcome to the Design and Prototype Studio in New Orleans. I'm in the prototype area for assembly. And this is the area of my studio where I basically practice building motorcycles so that we get the assembly sequence down, so that all of the torque values and all of the part sequences, where the parts should live on the shelf, where the pre-assembly area should be, can all be understood.
Awesome. And I think this space has been seen in some of our videos that are up on the Curtis YouTube channel, but we've never really taken a deep dive back here with you. So cool. All right, first question. This is a question we get a lot, especially from prospective customers and even investors. How easy is it going to be to manufacture the One?
Well, let me start by saying this. The job of a designer, once you get a motorcycle, a prototype running well and into validation, your job is only half done at that point, because everything about how to build the motorcycles needs to be fully documented and fully sequenced. And that is what's known as production design. So in other words, how do you design a system for consistently making perfect motorcycles so that the quality is always there? And what I've been working on since the design of the motorcycle is more or less frozen is going back and being sure that everything fits together perfectly. And it's a lot of work. How easy are these bikes to make? They're very easy to make because we don't have any fabrication. So the whole process of QC and welds and fabricated pieces, that's all gone. And our motorcycle is reduced to ones and zeros. So it's all digital. So alignment, fit, and finish is all dictated by ones and zeros. That being said, there are a lot of little tricks that you need to know and document, so that when the time is right, when we're ready to go into production, I can hand all of this off, all of this documentation off to our assembly team and head of production as a complete package that's ready to go. We are going to have to make some tools. Like there's an assembly fixture for our carbon composite structural girder blades. We have to make that tool. But it's already been designed. We just need to make it. Right now I'm doing them, 4 at a time by hand. We've also got to build a shuttle that will go down the assembly line that will raise and lower the motorcycle to put the job at hand, whatever sequence that is coming down the assembly line, in the perfect spot for the assembly. People come in all different shapes and sizes, and that includes the people who are going to be building these motorcycles. Having somebody with a workspace that's comfortable for them and tailored exactly to their needs, and every tool laid out in just the right spot, will help to assure ultimate quality of construction. So are the motorcycles easy to make? The short answer is very easy to make. The longer answer is that this process is what makes them easy to make. and has a lot to do with the original design. You know, when you're designing for production, it's very different than designing a custom motorcycle. So you can have a process on a custom motorcycle that's very difficult to achieve, but because you're only doing it once, it doesn't really matter, right? So production bikes need to have special attention paid to them in that regard. And I think I'm the right person to figure all this out, because I have taken apart and put back together hundreds of motorcycles and all kinds of very weird stuff. I'm a motorcycle mechanic as well as being a motorcycle designer, and I've always thought that mechanics, you know, guys who work with their hands, a lot of times their input gets left out in the assembly process, and you wind up with a lot of friction between management and assembly. But if the guy who's designing the line is a hardcore mechanic, I think it's going to make it a lot easier. The goal all along has been to be able to have this set up so that one person can build one bike in a week. And I mean a normal 40-hour work week. So that's 8 hours a day, working consistent, steady. It's going to be a lot of work, but joyful work, not frustrating, smooth, easy. One person, one bike, 1 week. And then we can scale it up. It'll be so easy to scale up from there once we get there. And we're pretty much there.
And that's actually the next question. That's a question we get a lot, is will you be able to easily scale production of the one?
Yeah, scaling, you know, from day one with the project, it's been a focus on the ability to have the fewest number of component pieces that do the most amount of jobs, so that we can have respect for the materials. So we're not wasteful when we're making these parts. There are very few truly complicated parts. And the ones that are fairly complicated, like the steering neck that's behind me, it's the simplest way to make a very complex part. But we start really I started with bearings. So this is our 15mm ID double row sealed needle bearing. This is a very expensive bearing. This bearing retails for $75. And we use this bearing everywhere on the motorcycle. There are no bushings in our suspension. It's all done with needle rollers. One of the reasons why the motorcycle rides so smooth is that there's no stiction. So knowing that this is the bearing that we're going to use for all of our linear motion on the motorcycle, the next step is to design a bolt, a beautiful bolt, proprietary bolt that fits into this bearing. And you'll notice in this bolt, you'll see this bolt everywhere on the motorcycle. And let me talk about just this bolt for a sec, because this is the foundation of our motorcycle, this piece of hardware. You look underneath, there's a little lip right there, right? That little lip is to accommodate a fiber washer like that, snaps in place. That fiber washer provides a little bit of protection for our sealed bearing. Now you'll notice that we have a divot here. That divot is built for a set screw. So that set screw locks this bolt in place so that it can never back out once it's installed and then the set screw put in place. This system is used throughout the motorcycle. The second bearing that I'm going to show you, and there's only two on the whole chassis, is this 40mm ID radial ball bearing. And the reason why we're using a radial ball bearing is because it's self-aligning. So this ball bearing is used anywhere where we have rotational motion, right? So wheels, drive shafts, all that is used This bearing is used for all of those parts. And here you'll see our pulley, right, with our drive plate. Fits on that bearing just like that. Beautiful fit. So with the fundamentals of our bearings, the whole motorcycle, of our bearings and our shafts, the whole motorcycle really grows from there.
Awesome. Yeah. The next question has to do with scale as well. Will scaling production affect the best and finest quality that Curtis promises?
Well, I hope I've already answered that question, but I'll go back into it briefly. It's about not designing a motorcycle. It's about designing a system. And the system of the motorcycle itself is a reflection of the system of assembly. So if you like the system that you see on the bike that Vinay and I have designed, then I think you're going to appreciate the system that lives behind that motorcycle, the back of house that produces that motorcycle. It's the same level of care and attention to detail and thought that goes into our assembly system.
Awesome. And we've got one more question for you today, JT, and it's a fun one, and it's something that's really at the core of this motorcycle. How far can you take personalization with the design of the one?
Well, let me show you a couple of parts real quick.
Please.
So this is our chassis side plate. In other words, this is half of a chassis of a Curtis motorcycle. This is the right side. There's a right and a left. And interestingly, this big, beautiful piece of 6000 series aluminum is actually a plate, and it's only machined on one side, right? So this plate, once it's fixtured, it never gets flipped upside down to be machined on the inside, which means that we can have a mill finish on the inside of this plate. It's only machined on one area, right? That saves us a lot of time. It was a lot of trouble to make it this way, by the way, because you have to, if you're mounting stuff on the inside of this plate, which we do a lot, that hole has to be generated on this side of the plate. But it makes it so much easier to manufacture, makes it much more scalable. And if you'll notice in this chassis side plate, there's a little groove. It's kind of hard to see, right? But there's a little groove machined right into that area. And what that does is that allows us to use inserts that fit perfectly into the chassis. What we're doing is we're converting hand-on paint into ones and zeros. We've basically digitized paint so that these laser cut panels now fit perfectly into our chassis without a whole bunch of taping and masking and labor involved with making these parts. So now that we have this shape digitally, perfectly modeled, we can make this out of any material. We can make this out of steel, stainless steel, copper, brass, bronze, fabric. We can make this out of titanium.
Wood.
We can make this out of wood. We can make this out of pretty much anything you could come up with. So because we have all of these shapes understood, we can now do mass customization and intense customization that's not disruptive to production. That was the goal from the very beginning, is to make something that can be personalized and yet doesn't require a whole bunch of experimentation, and also can be done quickly, efficiently, and most importantly, perfectly, so that every bike, no matter what the request we get, will be rendered perfectly. Here, let me show you another quick example.
Awesome.
So here's our very cool carbon composite bell card, right? And you'll notice there's a little groove in these carbon composite parts. That groove is to accept a piece of trim. And now, any color can be applied to this part, and every part will be interchangeable and perfect. On another thing on assembly sequence, wiring up the dash and all of the wires that go to the display and all of the handlebar controls, that's always been a real hassle. So let me show you how some of the thinking. This is our solution for that very difficult problem. So this is our steering neck, and it's all done as one big assembly with the dash and the wiring included. Let me show you how we do that. So our handlebar and dash and switch pods, which aren't on here yet, all get wired up. And then we have disconnects. That's what these funny tubes are. These click into the dash, and the entire wiring for the display and the switch pods is done. That's it. It's all done on a bench, which is much easier to do than trying to wire the thing on while it's on a lift. What else you got, Jordan?
Awesome. That's all the questions we had for you today. I think that was some really good insight. Thank you for taking us behind the scenes and into your mind as you work through some of the process of bringing this motorcycle to true production. Do you have anything else you wanted to add that's relevant to this conversation?
Well, I've built quite a few of these, and the knowledge for how they go together. You know, it's one thing to build a prototype. It's quite another thing. The question is, can you make a lot of them? And right now, I believe the answer is absolutely yes. We can make a lot of them.
And we're excited to start making a lot of them. Awesome. Well, thank you very much for joining us, JT, and thank you to everyone for watching. If anyone has any other questions that they want us to address, just send them in and we'll do another session like this.
That sounds great. I'm ready to answer any questions y'all have. I appreciate your time.
All right.
Bye.
Thanks, JT. Thanks, everyone.